Okay, good afternoon. Right, so today we want to finish our discussion on subnetting. So we discussed fixed size subnetting questions, including some past paper questions, because most of the years they have given you the fixed size subnetting questions, simply because it's easier. But in some years, they have given you variable size subnetting. Okay, so let's do that kind of question and possibly a past paper question as well. Okay. Right. So let's straight away go into our question. So now you know how to build fixed size subnetting. That means it's between always 32 to 64 or 16 to 32 and so on, right? Uh, right. So this is a variable size subnetting question. You can see that. Okay. So let's first do our example, maybe. Right. So let's do this particular question. Uh, 2022, paper 2, question 6B. Okay, question 6B. Let me copy this. Right. Suppose that ABC company has received. Okay, let me take the pen. ABC company has received 192.154.0.25. So 25 means /25 means you have 888. Okay, that 24. Then one more. Then all other bits are for you. 1, 2. Okay, let me. Okay, 1, 2. That is 6, 12, 24. So then here you have all these bits are for us to play with. That means 7 bits. So this is where the 25th, but this is not for us. This is for network. We have 7 bit to play. Okay, so that means either we can create a big network or you can break this into subnetwork by borrowing bits here. Okay, if it is fixed bit, if you need 2 subnetwork, you borrow 1 bit. 4 subnetwork, 2 bits. 8 subnetwork, 3 bits. 16 subnetwork and 4 bits and so on, right? But now let's see, you can see we need 4 subnetworks, IP address block to be distributed among 4 departments. That means we need 4 subnetworks. It is required, uh, that is also easy question, right? Did we do this question? Did we do this question? Because this is also 4 subnetwork, right? All are between 16 to 32. I think we did this, right? So let me double check. Did we do this? Did we do this? I think we are supposed to do this one. Yeah, we need 2023 paper 6. That is, given examiner has given alternative answers. That means you mix these things, right? Because you can call this C and maybe this P and this C. Okay, so just giving it, right? Is it clear? Right. So I want to do this one first. Okay. Let's do this one first, and then we can do that past paper question. Anyway, this past paper question you can do it actually. This is fixed size. Okay. Right. So where is this question? And do we have this slide? This one. Okay. Right. So let's first do this one. Then we'll get back to that past paper question. Okay. Right. So this question says anyway, it's also 24-bit. It's not 25-bit, it's 24-bit. Okay. This is not a past paper question. So this is our address block. We have got this 8-bit. 8-bit to play because 24/24 means this is your separation. Okay. So this time we want to create 4 subnetwork. 4 subnetwork. Look at the question very clearly. Now, if you need 4 subnetwork, if you just go by the fixed subnetwork approach, we need to borrow 2 bits because 1 bit, 2 subnetwork, 0 and 1. If I borrow 2 bit from 8 bits, then 0, 0, 0, 1, 1, 0, 1, 1, we have 4-bit patterns. So therefore, if you think it like, forget about this number of machines, you are going to borrow 2 bits because we need 4 subnetwork. But what happens when you borrow 2 bits? You have 6 bits to play because you borrow 2 bits out of 8, then you have 6 bits for the machines. So 6 bits means you can have only 2 to the power 6 minus 2 machines because remember 2 IP addresses, the first one and last one is reserved as net ID and broadcast ID. So that means if you go for the fixed size subnetworks, we are going to end up with 4 subnetwork have each having 2 to the power 6 is 2, 4, 8, 16, 32, 64. 64 minus 2, 60 machines. So that means, yes, we can break it into 4 subnetwork. Then the maximum number of machines for each subnetwork is 60. If you go by the fix, that is, all the other past papers were like that. For example, if the question says this is also like 55 or 48, so then we can say yes, because all these we get 4 subnetwork, we can go for maximum of 60. But this question says department A or the first subnetwork need 100 machines. Now, if you go for the fixed width, you can't allocate 100 machines, right? You can't allocate 100 machines for this department because the maximum you get is 60. So this is the type of question where this fixed size subnetworking doesn't work. So these kind of questions, you need to be very careful. Uh, right? It's doable. Okay, it's doable. Only thing is we need to think a little bit extra now. Okay, right. So this is how you do it, right? Because you have given this kind of question in your exam, A-level exams as well. So the first thing you need to do is you go from biggest network to the smallest. Anyway, in this question, it's already 100, 50, 25, 5. So therefore, your first task is create this biggest subnetwork and see how many bits you need to borrow. Because if you borrow 2 bits straight away, you can't create network with 100 uh, machines because maximum you can go there is 60. So therefore, let's check whether we can first build this subnetwork. So in order to do that, we need to borrow only 1 bit, not 2 bits, because when you borrow only 1 bit, you have 7 bit to play for the machines host. So that means how many, then you can create only 2 subnetwork. That is fine, but we are going to create only 1 subnetwork like that. Other one we are going to subdivide. So that is the purpose of subnetting, right? We are going to borrow only 1 bit out of 8 bits. So then we have 0 and 1 and 7 bit to play. And we are going to allocate one of these for our department A. One of these, either 0 or 1. 0 or 1. So that we have enough IP addresses for department A. Okay. So then we are going to break this one into subparts. The second one. If you take as it is, you get only 2 subnetwork. But we are going to break this into further. But let's first finish this one. Right? We only borrow 1 because if you borrow 2, uh, you can't give 100 machines. Okay, so that is the first step. So then you allocate for this one. Then you allocate for this one and so on. That is the approach. Okay, so it's a little bit tricky. Right, so therefore what we are going to do, we are going to take only 1 bit, not 2 bits initially. Right, because when you take 1 bit, you get 2 to the power 7 minus 2, that is 126 machines, 126 IP addresses. So let's allocate. Now we can either take 0 or 1 because this is our control, because this is /24. So let's allocate 0 for department A, or you can allocate 1. Okay, let's allocate 0, right? That is why in the exams you get alternative answers, right? Because student can say, okay, let's allocate 0. Another student can say, okay, let's allocate 1 for the department A. But always I allocate the smaller value to the, because then most of the time your answer is the main answer in your uh, marking scheme, so that someone who is marking your paper find it easy to give you the full marks. Otherwise, that guy need to uh, put more effort, right? So therefore, I'll take 0 for department A. Okay, department A. So that means one XXXXX is available for other networks, right? So therefore, what is the smallest? Uh, for department A subnetwork, of course, we get 2 to the power 7 minus 2 machines, that is 126 machines. Okay, that is bigger than 100. So the smallest number will be 0 and all zeros. Biggest number will be, because this is 0 now, and all 1. And this will be the subnet ID. This will be the broadcast ID for department A. Right? Department A. So that is 192.168. 1. Anyway, you don't need to convert this into binary anyway. 1 and 0. And this is 192.168.1. And when you convert this into base 10, you get 127. So therefore, now you have the first subnet ID, broadcast ID of the department A. So therefore, the first usable IP address for department A is 192.168.1.1. Last usable address is 192.168.126. Right? So that is our first part. Now we have allocated IP addresses for the biggest department, Department A. Okay. Remember, we used the 0, but this is still available. We have not allocated 1 and the other 6 bits to any of those. But if we just allocate these 4 other subnetwork, that means we have only 2 subnetwork. So therefore, we are not going to do like that. And here for Department A, subnet mask is 255, 255, 255, and this is 7 zeros. So that you can calculate 1, 2, 4, 8, 16, 32, 64, 120, 256. Sorry, 1, 2, sorry, we have only, there's one more 0. So the subnet mask for Department A will be 1, 2, 4, 8, 16, 32, 64, 120. 255, 255, 255, 128, or slash 25. Okay, slash 25. Or you can say 255, 255, 255, 128 within bracket. That is your subnet mask. It's same as saying slash 25 because we have borrowed, break it from here. And now we have the first subnetwork. But remember, this range is still available right? Because we took the zeroth one. Right? One is available. But we are rather than we allocate the entire block, what we are going to do is now look at what is the second biggest one. We need only 50. Right? We need only 50. Remember what we have is this one. Zeroth one is now already allocated. So what we are going to do is we are going to take one more bit. So that means 1 0 and 1 1. Because 1 is available. 1 is available. 0 is already used. Right? Therefore, now we can break it into 1 0 and 1 1. I took only one bit because we need 50 required. 50 means 64 because the 2 to the power is 64. So if you need 64 or 50 means 64, you need 6 bits, right? 2 to the power 6 is 64, right? So therefore we took one bit from that, that means 1 0, or you can take 1 1, right? So then 1 1 is still available for us because 0 is already used. Now 1 0 is used for Department B, then 1 1 is still available for other work. Okay. So then what is the smallest IP address for the Department B? 1 0 and all zeros. That is subnet ID. Broadcast ID is 1 0 and all ones. So that will be 191. And usable IP addresses will be 127.9 to 190. And this is, or you can say it is subnet mask is 255, 255, 255. Remember now we have 2 bits taken, 1, 1 and this. So you can write it like that also. So just calculate this. Okay. So that is now we have allocated IP addresses for Department B. We have allocated 64, that means 62 IP addresses. It just need 50. Right. Now we have 1, 1. 1, 1. Okay. 1, 1. And now we need, now you can't allocate this block to the other because we need 2 more subnetwork, right? So there we need 25 and 5. So remember 1 1 is with us. 1 0 is 0 already allocated. 1 0 already allocated, but 1 1 is available. Okay, 1 1 is available. That also we can now borrow one bit because 1 1 is available. So we can break it into 2. One for the first one we can give 0, other one we can give 1. Right? 0, 1. Okay. So that means how many bits for the host? 5 bits. 5 bits mean 2 to the power 5, 32, 32 minus 2, 30 machines. But we need only 25. That is fine. So therefore, we can give this 110 to maybe department C. 110 for department C. Okay, because 32 is enough for that. And maybe we can give 1 by 1 for the other department D. Okay, other department. So 110 for one C department, 111 for D department. So that means both can have maximum of 30 machines. Or else you can further, now this one definitely we can allocate for department C. 110, all zeros is the subnet ID, 110, all ones is the broadcast ID. The usable addresses will be 1932.224. And subnet mask is 255.255.255 triple 1 5 zeros. You need to convert it, right? That you can write within that, right? So now for the department D, either we can allocate 111 this range, or you can further subdivide to some more subnetwork and keep range for future development and allocate that. Or you can allocate this entire block assuming that uh, you don't keep any IP addresses, but this one is going to be more expandable. Okay, so there are two options here because 111 is there. Okay, one option is you allocate this entire block to the department D, or you just take the minimum number of bits required because you just need how many machines for department? 5 machines, right? 5 machines. So therefore, even this is enough. Right? 3 bits are enough because 3 bits being 2 to the power 3 is 8, 8 minus 2 is 7. So then 11100 you can give to the department D, then this block is still available for further subnetting. So that is the second option, right? Either you allocate this entire thing to department D, then you don't have IP addresses for further subnetworks, or you just allocate this part and keep this for future subnetwork. Any answer is correct. Any answer is correct. Okay. So here we have taken the minimum required uh, so that we have now this is available for future subnetwork. So of course we can create only small subnetwork, but still we can. Or else you can just simply say uh, this this entire block is allocated for department D. 110 for department C, 111 for department D. Then all zeros is subnet ID, all one is so now you have two possibilities. Both are acceptable. Right? So you need to think about this. Right? You need to think about this. It's a little bit challenging, but these questions are in A level they have given because I'm doing classes for BIT degree program. So these are actually in degree level. So most of the time the questions are variable size subnetwork because in reality we need different size subnetwork. But in A level, 75% of the time, 80% of the time they have given you fixed size subnetwork because this is some students find this little bit more too challenging for them to understand. But I don't think that it is too much challenging, right? You should be able to understand. But it will take a bit of time. You need to think about it, right? Right. If you have a perfect understanding about what is subnetting, what is this borrowing bit from host side to create further subnet, because subnetting is you can create a subnetwork and that subnetwork we can further subnetwork, further subnetwork, further subnetwork. It is not just 3 levels, right? So you can keep subnetting. So you break it into two, and this one you can break it into another two parts, or maybe this one you can break it into 4 parts. So it depends on how many bits you borrow. Sometimes this you can break it into 8 subnetwork, or just 2 subnetwork here, and this one you break it into 4. So likewise, a lot of flexibility is there. But only thing is you can break it into 2 to the power number of machines. Right? 2, 4, 8, 16, 32, 64. So when you need 50, you need to give 64. When you need 25, you need to give you must give 32. But that flexibility is there. Your subnetting is not just one level. That subnetwork you can further subnetwork. That subnetwork you can further subnetwork. Not just break it into two halves. No, sometimes four parts, eight parts, and so on. Of course, as long as you have enough number of bits, okay, enough number of bits. Right. I just kept it for last because I know it's a little bit challenging. That is why I took a lot of time uh, before discussing this particular question. Okay. Right. So, right. So now we can do a few more question, but before moving to that, I just want to finish our theory part. Now we are done with subnetwork version 4 subnetworking. Right. We'll do maybe one or two more questions because this is the most complicated, most difficult, but not impossible part in computer networking. Okay. In A level also, I told you there are some challenging areas. One is memory management calculation in OS. Another one is this subnetting, right? Another one is, of course, programming. In general, examiners can give you very complex questions. So these are the most challenging areas, right? Memory management, OS, we have already done. Subnetting in network, and examiner can give you very challenging questions when it comes to programming. So now out of these three, the most difficult, or according to the students, the most difficult things, now we have done two of those. Just we need one more thing to do. I mean the so-called difficult topics. Okay. So therefore, definitely you need to spend a lot of time, right? Uh, Sometimes you may feel like you have understood, but maybe still you are not very sure. So that sometimes you get to know that after about 2 3 months. All of a sudden you feel like no, I'm in doubt. So that is where you need to again think, or you need to ask questions and so on. Okay. Right. So now let's do a let's first finish our discussion on network layer. Right. Uh, so this is not something very important for you, but just remember this particular subnet IP range is often used to for a computer to refer to itself as a local IP address. This is a local IP address range, right? Most of the time, 127.0.0.1 to 127.255.255.255. These IP addresses, there are so many IP addresses here, like 127.0.0.1, 127.0.0.2, 127.0.0.255, then 127.0.1.0, and blah, blah, blah. All these IP addresses are, oh, actually, you don't need all these IP addresses. Any of these IP addresses are mostly used for to refer to yourself. Say, say my laptop want to refer to itself. So sometimes we call it localhost. So any of these IP addresses can be used, and most of the time the IP address used is 127.0.0.1. Okay, 127.0. In web development, you will find that sometimes we just type HTTP localhost, or else you can type HTTP 127.0.0.1. So basically, if you see 127.0.0.1, that means that machine is referring to itself, same machine, right? Same machine, not different machine in the network. Or anything in this range. Okay, anything in this range, like 127.0.0.255, 100 to 225 or something, anything in this range. Okay, but mostly it is this IP address. Okay, and so that is a very special case, uh, an IP address that used to refer to itself, same machine, not one address, any of these addresses. Right. So next subtopic is virtual LANs. Okay, VLANs. So this concept is getting more and more popular, but we are not going to discuss any technical things related to VLANs or virtual LANs. But what is the idea behind virtual LAN? Why do we need VLANs, and conceptual level how to create VLANs, not technical level. right? So far what we discussed is creating subnetworks by allocating different IP addresses. Those are physical different networks. For example, say first floor, one subnetwork, second floor, another subnetwork, third floor, another subnetwork. Okay. Say 0, 0, this subnetwork, 0, 1, this subnetwork, 1, 0, this subnetwork, maybe fourth floor, 1, 1, subnetwork. Right? But this now say first floor machines get IP addresses from this range, second floor IP at like this, or maybe these are department, HR department, finance department, and so on. So the disadvantage of this approach is, say these are allocated to different departments. So then finance department employees get IP from this range. Marketing department get IP from this range, and so on. So that is okay when you have desktop machines, because desktop machine in a finance department is going to be stay there, right? A desktop machine in HR department is going to be stay there in their network. It's right. Very rarely you take it to another place. Then of course you can reconfigure it as a not HR department computer, finance department, so that we can allocate different IP address. Right. So that is how we used to do subnetting. Physically different subnetworks. Physically. Right. But these days, people use more and more mobile phones, laptops, notebooks, and so on. And also, they don't just work in one place. Sometimes this guy will go some other department, and he or she want to connect to the network, his network. But now he is in the finance department, but he want to connect to his, say he's from marketing department subnetwork, but from the finance department. But this is physically finance department's subnetwork, but he's from marketing department. So then again, he need to go there and plug it because these are physical networks. So when people are getting more and more mobile, right, not staying in one place, but we need these subnetworks. Still, we need subnetwork for security and other things, but it must not be isolated by the physical location. Okay, physical location. So anyone, say these are four departments, anyone from any department must be able to connect to their network from any physical location. Still, he or she must be able to connect to his or her subnetwork as well. So that is where we have a concept called virtual LANs. So that means still we have LANs, different LANs, but those are not location specific. Location specific. So when you plug in your laptop, you are connected to say finance. Someone from marketing department connect to the company network wherever, right? So it must be connected to the marketing department's LAN, regardless of the location. So that concept is called virtual LANs. So not physically separated, rather logically separated. So far, physically also separated. But if it is a VLAN, virtual LAN, it's just logically separated, regardless of your place, physical location. Okay. That is called VLAN because it's more flexible. It gives the users more mobility, right? Mobility, flexibility to use or connect to their respective subnetwork. Okay. Right. So there are different ways you can create VLANs, right? So there are sometimes there are physical approach as well. Like you have, say you are in flow one, maybe there are some sockets for marketing department, some sockets for HR department. So if you are from marketing department, you connect it to the correct socket, but you have multiple sockets. But this is a very old approach, but still it's a virtual LAN because now say two departments, but department one employees have slots for in here as well as here. Department B employees can go anywhere but they need to connect to the correct slot, which is a little bit of a headache because you need to check. Sometimes there will be labels saying HR, finance, and so on. You connect it. So that is the old way of creating VLANs. It worked, but additional work. But these days, you don't use this approach for VLANs. Rather, when you connect to the network detect whether you must be connected to say department A VLAN, LAN or department B LAN. So that means first you register your machine, providing your MAC address, and say, okay, this particular MAC address is HR department. Because your MAC address is not going to be changed, right? Your laptop's MAC address is not going to be changed, laptop or your network card. So the system administrators will map each MAC address to correct VLAN. Say these MAC addresses are for the HR department, these MAC addresses are finance department. So then you don't need to pick a special port and plug it. You just plug it. Or if it is wireless, you just connect to the Wi-Fi by giving the correct password. So then that router or that server get your MAC address. Because always when you connect to a sub network, the network router or the any other device can get your MAC address, your machine's MAC address. So then already these are pre-configured. System administrators have added which MAC address is for which local area. So then you will be automatically connected to the correct LAN. Right? It doesn't matter where from where you connect to the network. All of us are you are in the correct subnet. So that is true virtual LAN, right? Right, true virtual LAN. So that is because here you need to connect to the correct one, and also these must be separately wired. But here there's no such need. Okay. At any time, if you move from HR department to finance department, that means not physically, you are transferred. So then you can ask your system administrator that, okay, now I want to be in the not in the say finance department, I want to be in the HR department LAN. I must be connected. So then they will change this uh, VLAN table. So then from that point onwards, when you connect to the network, you are connected to the HR department. So this is more flexible. But that concept of subnetting, all these are there. All these are there, right? Subnet masks, all these are there for these different networks. But the only thing is they are not physically separated, rather logically separated. Okay. Right. So that is called virtual LAN. So this is mentioned in your syllabus. Okay. This is mentioned in your syllabus. So far, they have not asked any question. But by the way, I don't know whether they have asked any question on this year's paper because I haven't seen this year's A-level paper yet. But I heard that it's pretty difficult paper, students saying, but I haven't seen the paper yet. Okay. So far, like up, not I don't know about the 2020 four paper, but so far, sorry, 25 paper. Uh, Before that, they have not asked about VLANs, though this is clearly mentioned in the syllabus. Okay, right. So, any questions about that? That is called virtual local area networks because your subnetwork is not separated physically, rather logically by mapping MAC addresses to different IP address ranges. Okay, right. So that is called VLAN. Right. So the next question, next subtopic. So we don't go into details about these subtopics, right? Just a little bit of a tiny idea only. Okay. So next one is network address translation. Okay, network address translation, NAT. Okay. So what is network address translation? Remember, we discussed that when it comes to IP addresses, one thing we discussed that okay, we have class A, class B, class C, and other classes are reserved for some other purposes, right? So that is all the IP addresses are separated into different classes. Right? And remember, class A, class B, class C, there are sub ranges in class A, class B, and class C. We call them local IP addresses. So class A, there's a local IP address range. If it is not in local IP address range, it's a public IP address. In class B also, there's a local IP address range. Class C also, there's a local IP address range. So why do we have local IP addresses? Right? So for example, I briefly explain about what is local IP address. For example, if I type command line, take a command line, and type ipconfig. So this is basically my local IP address. This IP address is not something the internet can understand. Okay. This is my router. Identify my machine as 192.168.110, which is a local IP address. My actual public IP address is the public IP address of the router. That IP address is from the public range. And at this time, only my machine must have that public IP address. That is unique. But this can be thousands of others having this IP address, local IP address in so many other local networks. Now, if I want to check my public IP address, I told you can just type what is my IP. Go to a particular website. You can see 112.134.255.139. So that is my public IP address. This is my private IP address that is used only inside my local area network, 192.168 address. But this is my public IP address. So if you want to connect to my machine, you need to connect using this IP address. Right? This IP address. This is public IP address in Sri Lankan range. So every country has given different IP address ranges. And Sri Lankan IP addresses are subdivided into SLT, Mobitel, Dialog, and so on. And this is IP address given to SLT. That is why they can even tell, right? You are from Colombo, Western Province, Sri Lanka Telecom, and so on. Okay. By looking at this, yes, because this is a public IP address. So that means we have private IP address and public IP address. Right? So then someone will ask, why do we need this kind of a thing? So the simple answer is we are running out of IP addresses. Okay, we are running out of IP addresses. So therefore, multiple private IP addresses can be mapped to single public IP address. Right? Right. For example, remember I told you that range of IP addresses can be assigned to organization. Range. Say that range is 10 IP addresses. Say it's 16 IP addresses. So that doesn't necessarily means only 16 computers you can have in your network with internet connectivity. Sometimes those 16 IP addresses can be used to give internet connectivity to maybe 256 machines. Okay. So one IP address can be used to give internet connectivity to maybe 8, 16, 32 machines. So there are ways to map those things. That is one public IP address map to one local address or many local IP addresses. Right? How it is done? Don't worry. That is beyond your syllabus. Just you need to aware that there's something called local IP address. There's something called public IP address. And there's a mapping between local IP address to public IP address. It is not always one-to-one. It can be even many-to-one. So that means many private IP addresses map to one public IP address. So this mechanism of translating your public IP address to private IP address when you receive a data packet. And when you're sending a data packet, your private IP address we need to convert to the public IP address. So that is called network address translation. Right? Network address translation. Okay. But again, don't try to understand this 100% because there are small gaps because it takes a lot of time and it's not necessary for you at A levels to 100% understand how this translation is done. But only thing you need to understand is there are IP addresses called private IP addresses, there are public IP addresses, and there's a mapping mechanism between private to public, which is done by your network server or router. It is not always one-to-one. It can be multiple private IP addresses are mapped to one public IP because we are running out of IP addresses. So that is why we need one public IP address shared by many private IP addresses in a local area network. Still uniquely identify those. Right? That mechanism is beyond your syllabus. Okay. So that is called network address translation. As I told you, it can be one-to-one. That is one private IP address mapped to one public IP address or one-to-many. That is one public IP address mapped to many private IP addresses. So in that case, we use something called port address translation. We use something called port address to do that. So therefore, that is a special case of NAT. Sometimes we call it PAT. So therefore, port address translation is a special case of network address translation. Okay. But how it is done, let's not discuss. Okay. Just a rough idea about what is it. Rough idea about what is it. Okay. Not beyond that. Right. So now we move on to IP data packet structure. Remember, in routing, the smallest unit is called data packet. Sometimes we call it data packet, sometimes we call it IP packet. Data packet. Data packet. It's a chunk of ones and zeros at machine level. Data packet or sometimes we call it IP packet or sometimes we even call it IP datagram. Right? IP packet, IP datagram, same thing. So this is network layers view, network layer, smallest chunk. Remember in logical link layer, data link layer, it's called frame. Right? Sometimes the frame, one data packet is basically few frames. Or one frame is one data packet, right? But this is the view of a network layer. The routers look at the data packets, not the data frames. Switches switch the data frames, smaller units. Right? What is the structure of a data packet? In data frame, it is source MAC address, destination MAC address, payload, and checksum for error correction. That is why we say data frames layer 2 concept and switch is a layer 2 device because switch data frames by looking at the source destination MAC address because it has a MAC table, right? MAC address and which physical port. So if the destination MAC address is mapped to port 2, so that data frame is sent to port port 2 to the correct machine. So therefore, the frame is very simple. Source MAC address, destination MAC address, payload, checksum. Checksum is for error detection and correction. But when it comes to IP address, IP packet, because that is the layer 3 concept, network layer concept, this is what the routers are looking at. Routers look at the smallest unit as a data packet or IP packet. So it has source IP address, destination IP address, not the MAC addresses, IP addresses. And some other things like IP version, whether it's V4, V6, a packet size, packet sequence number is there because remember these data packet can go out of sequence because these different data packets can reach the destination using different paths. So therefore, you don't always get the packets in the same order. So this packet sequence number is used to assemble them in the correct order, because maybe these data packets are related to a web page. Sometimes you may get the 10th data packet before 6th data packet, 9th data packet. But you need to assemble in the correct order. That is why when they break the data packets at the source, uh, at the packet sequence number, so that the destination, it can be assembled in the proper way. Okay. And of course, payload is the data itself. And again, some checksum for validation at network layer and so on. But the most important thing is you have the source IP address, destination IP address, and packet sequence number. So routers will look at your destination IP address and decide whether to route this way, that way, and so on, based on the IP address and the subnet mask. Okay. So exactly how this is done is again beyond your syllabus. Okay. So actually it uses subnet mask to look at that IP address, and that will be resolved to the subnet ID of that network, and then it will be routed to that subnetwork. Okay. Uh, right. So this is the structure of a IP packet. IP version, source IP address, destination IP address, packet size, packet sequence number, payload, and some checksums. Okay. But you can forget about the checksums and packet size, just even IP version like source IP address, destination IP address, packet sequence number, and payload. Okay. So it always routers look at the destination IP address, which must be a valid public IP address, and route it towards the next router. That router will again look at it and route it towards the next router. Ultimately, it reach the destination. It is not like switching. Switching is switch to the correct machine. Routing is route towards the correct destination. Right? It's like you don't know exactly where is it. You just show an address. So this is from physical real world scenario. Someone in a junction and ask, I want to go there. So that guy will say, okay, you go that way. So then another junction. So that junction again you ask, that guy will say, okay, go in the third exit. So that means ultimately you are reaching the destination with the collaboration of these routers. Right? Routers. Okay. Yeah, it's an advanced concept, but we look at the high level thing only here. Okay. Right. So that's it about IPv4. Okay, IPv4. Right. So remember, so far what we have discussed is IPv4 and its routing, subnetting, uh, port address translation, and so on. But remember, now we are in a transition. So this is my local IP address V4, and this is my V6 local IP address. That means even local IP addresses, we have V6 now. And here also, this is my IPv4 public IP address. And you can say this is my V6 public IP address. So that means we have now IPv6 IP addresses also. Right? Both V4 and V6. Right? Both V4 and V6. So why do we have V4 and V6 addresses? Because as I told you, we are running out of V4 addresses. Actually, we have already run out of V4. That is why we have network address translation where multiple local addresses are mapped to one public IP address. Okay. Because earlier, when V4 IP addresses were format was decided, that is in 1990s, they thought, so this is 8-bit, 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 8-bit. So that means uh, 0, 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1, 1, 1, 1. That means 256 possibilities. Another 256 possibilities. Another 256, another 256. Right. So this number they thought is enough for internet. Right. So that is basically 256 into the fourth power. 256 into 256 into 256 into 256. Okay, so this is 4,294 millions. But remember, out of this also, class A, B, C, D, and E is not for subnetting. Right? So therefore, it's less than this. And they thought this is enough. But now internet is all over the world. So therefore, now we are this much of IP addresses are not enough. Actually, you can't use all these things also because class D and E is reserved for other purposes. Okay. So therefore, now we need a bigger width IP address. For example, you know that in Sri Lanka, earlier we had two-letter uh, vehicle numbers. So then they extended to three letters because they found that okay, two letter is not going to work, not enough. Now vehicle numbers. That is why sometimes you will see some vehicles with two English letter and the number. But now we have three English letter. Right now, I think it's in the CBO series now. CBO these days. Then CBP and so on. But earlier we had something like AB, AA, AB, AD, GT, and so on. So that is also because two letters are not enough. So then they extend to three. Same thing. Now we have V6, version 6, right? Version 6 IP addresses. Why? Because two reasons. One is version 6, we can have larger number of IP addresses because it is not 32-bit. IPv4 is 32-bit, right? Each one is 1 byte. 1 byte, 8 bit, 8 bit, 8 bit, 8 bit. That is 32-bit. But IPv6 is 128 bits. That is 4 times bigger. Not twice, 4 times. 4 times. So there you have huge number of IP addresses. It's not going to be fed up. Okay. So we are not going to have another version of format of IP addresses because 2 to the power 8 is huge. Right? It's not even trillions of IP addresses. So that is one problem is solved there. We are going to get enough IP addresses so that every machine can assign a unique IP address. Then you don't need IP address translation also, private to public. Okay. So that is one reason. The second reason is with IPv6, it's a Internet Protocol version 6, even they improve the data packet structure and some other features are added to the Internet Protocol. Okay. So therefore, it's not just bigger IP addresses or large number of IP addresses, some more enhancement to the data packet structure and some other features. So, and remember when it comes to V6 addresses, V4 addresses, we use base 10 numbers, right? Like 128, 205, 38, right? 57, and so on. So maximum is 255, minimum is 0. Anything between 0 to 255 here, theoretically. But in IPv6, we write it in hexadecimal, right? Not in base 10. So that is why here you see uh, it's a hexadecimal number. Okay. And also here we use dot, here we use colon, right? Here we use dot, here we use colon. Okay. So how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. This one is 4 parts. 4 parts, but this one is 8 parts. But 8 part doesn't mean that it is the width is twice. No, because this is 1 byte. This is 2 byte. So therefore 2 byte into 8. Okay. So therefore it's bigger. So the first thing you need to understand is it has 8 parts. So these are the important points for you to remember. it's a 8 part, not 4 parts. 1, 2, 3, 4, 5, 6, 7, 8, and separated not by period or dot, rather colon. Right now, I have mentioned two things. It's 8 part, not 4 part. It's separated by colon, not dot. Third thing is, in V4, we use base 10 number. In V6, we use hexadecimal number. That is why you have A, B, C, D, E, F also, here and there. Okay? It's a hexadecimal number. 8 hexadecimal numbers. The smallest hexadecimal number is 0000. Biggest for one part is FFFF. Okay? So these are very simple things, right? Right. So that is the structure of IPv6 address. Okay. And there's a small convention we used in IPv6 address representation. That is, if you have this block of zeros, we can write it like two colons. Right? Two colons. So that is just to make it a little bit more compact. Okay. Uh, but anyway, that means it has set of 0 blocks. Okay. 0 blocks. And now we are in a, for example, if you see something like this, now you can see uh, here we have colon twice. And what now this is the slash notation. 1, 2, 3, 4, 5. Usually we need 8, right? So that means this is 3 set of zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Then 1, 2, 3, 4, 5, 6, 7, 8. So therefore, this can be one set of zeros or 2 blocks, 3 blocks, and so on. How many blocks? You can calculate by how many we have. 1, 2, 3, 4, 5, altogether 8. That means this means you have 3 0 blocks. 3 0 blocks. Okay, that is just to make it compact. Right, so now we are in a transition period. So sometimes you might be wondering why there are two IP addresses now. Right? Local IP addresses also, there's a V4 and V6. Public IP address also, there's a V4 and V6. The reason is we can't just switch off V4 and say that, okay, from this date onwards, we are into the V6. You can't do like that. Right? So just like when you go to the roads, there are two English letter vehicles, three English letter vehicles. Even then you have the dash one, right? Number dash one. Oh, very old. So they need to coexist. Naturally, after some time, these two-letter vehicles will be less and less and less and less and ultimately almost nothing. Same thing, you can't say no V4 addresses supported because there are plenty of all routers, other devices manufactured about 5 years, 10 years, even 15 years ago. At that time, there was nothing called V6. So those routers are not aware of V6 addresses. These routers are made to route using V4 addresses. So that is why when you are for each machine, you get both V4 address and V6 address. So your data packet will also have the V4 address and V6 address. Actually, from V6 address, we can see whether it's actually a V4 address, valid V4 address. Actually, not two addresses. So the V4, some V4 addresses, V6 addresses, we know that it's a V4 address as well. But some addresses, they are not V4 addresses, they are only V6 addresses. Some ranges. Okay. So that is why we have both that IP addresses. For example, my laptop support V6, but I get both V4 and V6 because my data packet may go through a router which only aware of V4. So then it use my V4 address or my public V4 address. Okay. Because we are in a transition. right? After sometimes maybe another 5 years, 10 years, we can say, okay, V4 is not supported anymore, right? But not yet. For very long period, for the last 5 years, we are in this transition, and I think maybe we will be there in for another 5, 10 years before telling that V4 is not supported. Okay. So the way subnetting is done in V6 is different. But in your syllabus, we only concentrate on V4 subnetting. That is what we learn. But we just learned that there's some V6 address and what is happening, what is the V6 format, and so on, and why we need V6. But not how to do subnetting in V6. Okay. In the exams, it's 100% V4, but you need to aware that there's something V6 and why is it like why do we have V6, but not how to do subnetting in V6. Okay, right, right. So now we are at the end of the network layer, like very end of the network layer. Uh, right. So we'll take a small break and do those small concepts and maybe do few more past paper questions. Okay. Right. So now the time is 5:10. We'll start at 5:20. Uh, so the next part of the network part is easy. Now this is the hardest part. Now we have finished hardest and challenging part. Okay. So then we can quickly do in another 2 or 3 sessions. We can finish the network subject. But by the way, network is subject is the biggest subject in your syllabus. Network programming. Those are the two big subjects. Okay. Right. So we start at 5:20. Okay, so let's continue. Right. So far we have discussed our focus was mainly IP addresses, IP data packets, and routing. Okay. So you can see everywhere we have IP address, IP data packet. Okay. So IP is the main protocol in computer networking, or especially in internet, right? IP, Internet Protocol. But network layer, now remember the physical layer, there are no protocols because protocol is standard for communication. So it determines the structure of IP address, structure of a data packet, and so on. It's a standard. It's a soft concept. So there was no protocol for physical layer. Logical layer also not much. Okay. But we have protocol in network layer that is main protocol in the internet also, internet protocol. So in above layers, you will see TCP, uh, UDP, then HTTP. So we are going to look at those things in upper layers. But in network layer, the main protocol is what? Internet protocol. So Internet protocol has defined the structure of IP address, V4 or V6, structure of a data packet, and so on. But other than IP, Internet protocol, there are some more protocols in the network layer. Right? Network layer, we have few more protocols. So out of those, we are going to briefly look at two more protocols. At least you must aware that these two protocols are also in the network layer, and very briefly, what is the purpose of each of these two other protocols? What are those? The Address Resolution Protocol, ARP, and Dynamic Host Configuration Protocol, DHCP. Right? We will briefly look at what is dynamic IP address is. Okay, so therefore this is not absolutely new to you, but there's a protocol called DHC. Right. So first of all, other than IP, Internet Protocol, there are two more main protocols in network layer. What are those? ARP, DHCP. Right. What does ARP protocol doing? Okay. Address Resolution Protocol. So this protocol can convert your MAC address to IP address or IP address to MAC address. This way or that way. Okay. So remember when you connect your machine to a network, so that means your home environment, you have a router, Wi-Fi router. So when your laptop connect to the network by entering the password or it's automatically configured, you have saved your password. So the moment you connect to your network, the router update, give you IP address and take your MAC address. So when your machine connect to the router or the network, the machine send its MAC address to the router or the network server. So then the server will give you, the router will give you the IP address, local IP address. So then that server or router keep track of which IP address is given to which MAC address. So that table is with that server. Right? That table get update when the machine disconnect and so on. So then that entry is deleted because that machine is not there. When that machine again connect or when other machine connected, another entry is added. So that means your router has the mapping between IP address and MAC address. So if any other machine, because say this is your router, right? This is your router has this table. If any machine want to find the MAC address given IP address, say this machine know the IP address of this, but it doesn't know the MAC address of this. So then it can use ARP or the Address Resolution Protocol query to send the IP address and ask what is the MAC address. Okay. So you query from this router, not from this machine. Or if it has the MAC address of this machine, it can send the MAC address and ask, send me the IP address of this machine having this MAC address. So that kind of queries can be done using ARP protocol. So that is why we say address resolution protocol. It can resolve MAC address to IP, IP to MAC. Okay, because router gives you that IP address, router or the server. And therefore it keeps track of which IP address is given to which MAC address. So therefore at any time, it can tell if someone asks what is the MAC address of this IP address, what is the IP address of this MAC address. So your router can tell it or your server can tell it. So that those queries are done using ARP protocol, right? Address resolution protocol. So just simple idea is enough. Okay, very simple idea. First of all, what is ARP? ARP stands for Address Resolution Protocol. ARP is another protocol in network layer. What it does, it can translate or it can provide IP address of a MAC address or MAC address of IP address if it is a valid address. Okay. Is it clear? Right. So the next protocol is the third protocol in network layer that we are interested is DHCP protocol. First of all, you must know what DHCP stand for. DHCP stand for Dynamic Host Configuration Protocol. So the word itself says dynamically configure the host machine. Host is any machine connected to the network. So remember, we can assign IP addresses two ways. I explained that at the very beginning. One is, say these are the machines in the network. This is your router or the server. One is when you connect, that machine is assigned an IP address, dynamically assign an IP address, which is always a dynamic IP address, or even it can send you a static IP address. Second way is you configure the IP address in that machine itself. That is always static. But these days, we don't go to the machines and configure because it's additional work or the user need to configure it by himself or herself. So these days, we mostly do is almost 100% of the time. When a machine is connected to the network, if it is a valid machine or uh, router or the server will assign the IP address. So how do we do that or how this is done? The machine and the router communicate through DHCP protocol. Protocol is a communication standard. Right? So this kind of activities, the communication happen through DHCP protocol, not IP protocol or ARP protocol. Okay. So if a machine get a dynamic IP address, basically it has communicated with the router and get that IP address using DHCP protocol. Okay. Right. So that is called DHCP protocol. So these are practically used in our even in our home Wi-Fi local area networks. Right? VTDH. So basically, not we, the machines communicate through DHCP and get IP address. Okay. Right. So that's it. So three protocols: the main protocol IP, then ARP and DHCP. Right. So now we move on to our final subtopic under network layer. Anyway, we have discussed this in a way, routing. So if someone asks what is the main task of network layer, it is routing. Okay. So first of all, you need to understand the difference between switching and routing, or the a device called switch and router. Switch is a network device, router is a network device. Okay. It may look similar physically. Okay. If I search router versus switch, physically look the same, but internally its functionality is different. Okay. So this is a router, this is a switch, this is a router. Of course, these days we don't use modems. Okay. You can see it looks pretty much the same. Of course, this is a wireless router. Right. You can see by look of it, you can't say which one is router, which one is switch. But internal functionality is different. Right. Internal functionality is different. And these days, more and more routers are wireless as well, but switch can also be wireless. Okay. Right. So router's task is routing. Right. It's not one router. Switch is one switch for one network. You can see this is a switch. Now you remember some part, almost every year second paper network question they ask you to draw a network diagram. We skip that part when we do the past papers. We just did the subnetting part. So when you create a subnetwork or a local area network or subnetwork, what we need is a switch, and the machines are connected to switch. And switch operate in link layer or the data link layer. So when a data frame reads the switch, switch can switch it to the correct machine because it has a MAC address to port number. These are the port 1, port 2, port 3, and so on. So therefore, it's simple task. Just data frame comes and it switch to the correct machine based on the MAC address of these. Because that is why we say it's operate in link layer because MAC address is a link layer. The smallest unit is data frame. Data frame has source MAC address, destination MAC address, payload, and trailer or the parity bits. So these are switches. So if you want to create a network, you need a switch. If you have 5 network, you need 5 switches or 5 subnetwork. This is department A, department B of building 1, building 2. Okay. Now these are routers. Routing is more complex. Number one, if you want to connect to internet, you need a router. That is why in your home network, you have a router. So that is not connecting to network, that connect your local network. Maybe it's just few machines in your laptop, your smartphone, and so on to the internet. So if you need to connect to internet, you need a router, not a switch. So then in our home environment, both switch and router is the same because we can directly connect it to this router, our machine, rather than a switch. But in bank or something, business organization, we have multiple subnetwork, then you need multiple switches connecting to the router. You need to understand this gradually. Remember, switch is layer 2 device. It operates on MAC address. It switch frames, whereas router is a layer 3 or network layer device. So routers look at the data packets and route it. So now you can see when a data packet reaches the router, it can route it this way or that way. Maybe this router can route it this way, that way, or this way. This router can route it this way, this way, this way, this way, this way. These are related to different subnetworks. So therefore, routing is more complex task. Router will look at the destination IP and the subnet mask and determine which subnetwork it want to route it. Then that data packet reach this router and this router will decide which subnetwork. Ultimately, the data packet will reach the exact machine. So these routers collaboratively route it towards the destination. So therefore, routing is more complex task. These routers must aware of what are the subnetworks, there are subnet IDs, subnet masks. When a data packet is reach your router will look at the destination IP address using the subnet mask, and then it will any IP address that will resolve into one of the subnet IDs, and then it will route it to the correct subnet or correct towards the correct router. Okay, so that is a more complex task. and these routers need to communicate with other routers, and they get the traffic details because sometimes there will be a lot of traffic here because there are multiple paths. If a data packet need to go there, it can go this way or it can go this way. If there's a lot of traffic here, maybe it will choose this way. So then these routers communicate with other routers about the traffic situations and so on. So therefore, routing is more complex task. There are routing algorithms which we are not going to look at. Okay. So routing is more big picture tasks, internet related tasks, whereas switching is more local area network related or local tasks. Routers use IP address for routing. Switch use MAC address. Right? So these routers, global level routers use public IP address. Your local router can use private IP address for internal traffic and public IP address for internet side. But these are the internet routers in the internet, the backbones and so on. So these routers only aware of public IP addresses. Remember, public IP address is geographical related, right? If it is a Sri Lankan address, uh, so these routers know it's a Sri Lankan address. You must route it towards, say, Sri Lanka, not towards USA. So public IP address has a geographical meaning. MAC address, no geographical meaning. Private IP address, no geographical meanings. But public IP address, there's a geographical meaning. That is why these routers can send it towards the destination. Okay. So you need to understand this. Not at very technical level, but reasonably conceptual level. Okay. So therefore, yes, it's a more complex task. It's based on layer 3 network layer. It's based on IP addresses. Routing is done for the data packets, not data frames. Okay. Right. So now we have done uh, our topic, layer 3, the biggest layer. Biggest layer means your syllabus wise. Okay. Right. So now we can do few more past paper questions. Right. So let's do this one. Okay. So this is 2021 paper. This is again, it looks like variable size network. You can see 64, 16, 32. Okay. So let's see whether we can break it into fixed size, because if you have enough IP addresses, even 16 is when 16 is needed, we can give 64. But if you are running out of IP addresses, we need to go for the variable, right? But take one bit, then other bit is subdivided into two, and so on. Okay. So this is 2021 paper. So let's read the question very carefully. ABC company has two main divisions, namely production and marketing. That means you have production, marketing. Under the production division, there are three units called store, supplies, and operations. So that means this first we need two sub network, and this sub network we need to further divide it into three sub network. I told you we can go into any levels of sub network as long as we have enough IP addresses in that range. So this is your past paper, right? This is not my question paper, right? This is A-level ICT paper. So that is why you need to look at the reality, right? I can just do few simple things, but when the exams are nearing, all of a sudden, students see the reality. Then it is too late. But I show you the reality at the very beginning. Right? I'm a realistic person. So that you have enough time to face the reality. Right. So then Operations, sorry, under the production, you have stores, supplies, and operations having 10, 12, and 18 computers, right? 10, 12, and 18 computers. That is stores, supplies, and operations. Stores, supplies, and operations. So 10 means we need to allocate 16 machines because remember, we can allocate only 2 to the power because 8 is not enough. 12 means again we need to allocate 60. 18 means now 16 is not enough. We need to allocate 32. You can see number of nodes. So these are given. Even though these are not given, you must know that okay, 10 means it's 16, 12 means 16, 18 means 32 minimum. Of course, if you have enough IP addresses, you can allocate 32. So then marketing division, that is the second big division, has 40 computers. So 40 means 64 because 32 is not enough. So basically, this is the first separation, and this is subdivided into 3 sub networks again. 2 sub network, and this is further divided into 3 sub network. Okay. Right. So now you can look at this one because this 12, 18 now basically 16, 16, 32, 64. Okay. But you must have this big picture now. Uh, so you first break like this and then subdivide like this. Okay. Uh, Now you don't need to worry about this 12, 18 because it's 16, 16, 32, and 64. Okay. ABC company has given this block, 25 block. 25 means 8, 8, 8, and one more, like one more. So then rest of the 7 you have 1, 2, 3, 4, 5, 6, 7. So these are the host bit that you can borrow to create subnetwork. Or else you use one network. So then, but that is not going to work because you first need to divide it into 2 parts and then second part you need to divide into 3 parts. Okay. So what is this is not one IP address. This is range of IP address, right? Don't think that this is one IP address. You have given a block, right? And see address block. Block means not a set of IP addresses. So this is how you give it, right? So what is that block? 192. 174.19.0. 0 means 8 zeros. 1, 2, 3, 4, 5, 6. So but you have this up to this point because it's 25, not 24. So these bits under your control, but this 0 is 0. This 0 can't be 1 because what you have is 0. Okay, 0. If you have any doubt, any questions, you can ask because I can explain A to Z. Some things I don't explain to you guys, because it's too much for A level. But if you have doubt, I can little bit explain more depth. Okay, but that I don't do it because otherwise it's too much for you. I just try to explain the minimum required for A level. Okay, right. So this is the block we have. ABC company are to be assigned IP addresses after making the subnets from this address block. That means first you need to break it into 2 subnetwork, and the second subnetwork you need to break it into further 3 subnetworks, sub-subnetworks. The following incomplete table shows subnetting. Copy it to your answer sheet and fill the empty entries. So, because remember, students can assign different ranges to different sub-departments, right? So then the examiners, when someone is marking, so their task is more difficult because they need to check whether you have assigned this range to X or Y or Z. So then the marking scheme also, there must be alternative answers. Students can assign this range to marketing, this range to stores, or this range to store, and right. So therefore, in order to prevent that, what the examiners does is they give you bit of a guideline so that everyone either It's very easy for them for check whether your answer is correct or not. Otherwise, the marking will take more time, right? More time, and that even the someone who is doing the marking can also make a mistake. So then it's unfair for the students because teachers are also not perfect, right? Sometimes they also make mistakes. But when they give like this, it's very easy. So everyone get the same answer if it is correct, or if it is wrong, we can even detect it fast also. That is why they give this kind of a sort of a hints. Okay, it's good for you students, good for the marking people, teachers, those who are doing the marking, and it's easier for the examiner also because he can just give you one uh, model answer, not multiple answers. Right. So now your task is so this is the A question. Fill the rest of the stuff. Right. Fill the rest of the stuff. Okay. Right. Is it clear? This is very challenging question, right? So these, but if you can do this kind of question, like of course we did this kind of question, right? That department A, B, C, D with different sizes. Right. So clearly you can see this is not fixed size, but see whether we can allocate fixed size blocks. Because what we need is here 64. Now, if I take one bit, of course, one bit is not enough because then you can have only two subnetwork. But initially, you need to take actually one bit only, okay, to make it marketing and production. So this is production. But then the other bit you need to further divide, right? You need not. So that means first you can take this bit. So that 0 and 1, because this is not 0, right? These are our bits. So this 0 we can't change to 1, but this is not 0 actually. These are our plain bits. Beyond 25, it's us. We have the flexibility to make it 0 or 1. So if I take one bit, then we can break it into two, marketing and production. So then I'm just thinking possible way. Then here for the production, we need to take two bits so that we can create four subnetwork. Though it is three, we will be creating four subnetwork. But in that case, how many machines we can allocate? 2 to the power 3 minus 2. 8 minus 2 is 6, but this is not 6, this is 16. So therefore, this is going to be tricky. And this is going to be tricky. Okay. Right. So remember it's 25. 25. Right. So let's first create this one, 64. 64. Say assume we take one bit because this is the block we got. This is the block we got. This 0 we can't touch. But these things we can handle. This is us, not 0. 6 of those. Not 6, 7, right? Because all 8. 1, 2, 3. Okay, let me show it again. This 0 we can't touch. This 0 we can't touch. But rest of the stuff we have the control. 1, 2, 3, 4, 5, 6, 7, 8. Okay. To break it into these two, we will take one bit. That means we are going to break it at here. And we can assign 0 for one, 1 for the other one. If you take 0, the network IDs, remember we can have 0 here, 1 here. So let's take the 0 one because this is 0. So when you take 0 1, it is 0 and all zeros is the first IP address. 1, 2, this 0 is already there, right? Because that is 25th bit. 25th bit is not us. 26 onwards us. So therefore we have 0. We took 0 here, then two zeros and four zeros. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, here I have drawn one more. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Right. So therefore, it will be the first address will be 0, 0, 0, 0, 0, 0, 0, 0. That is 192.174.19.0 because all zeros mean 0. Right. So how many nodes we are going to get? Now this 0, these two bits are not our control now because this is the block. We get these from here and this is 0 and 1 we are taking. So therefore, all the 2 bits are reserved. We have 6 bits. 6 bits mean 2 to the power 6 minus 2 usable, but addresses 2 to the power 6. 2 to the power 6 means 2, 4, 8, 16, 32, 64. Yes. So then we get 64 nodes, but 62 usable addresses. So then the subnet mask will be, or the broadcast ID will be, this is all zeros. The broadcast ID will be, this is 0, 0, 0, 0, 0, and all 1. And remember, other one we can use 0, 1 for others. That means for these three. Okay. But for this 0, 0, others 0, 1. So 0, 0, all zeros is the first address. 0, 0, all 1 is the last address. So what is the last address? That will be the broadcast address. 192.174.19, 1248, 1632, 64 minus 1, 63. 63. So the usable address range will be 192.174.19, 1 to 62. Right? I just write last one, 1 to 62. And what is subnet mask? So now the separation is after 2 bits here because this is 0. Other, we are going to take 1 for these three. So therefore subnet mask is 255, 255, 255. Here 2 ones and 6 zeros because now the separation is here. So 2, 1, so therefore this will be 255, 255, 255, 2 ones because we have borrowed 1 bit, 2 ones and all zeros. This is not IP address, this is subnet mask. 2 ones and 6 zeros. 1, 2, 4, 8, 16, 32, 64 plus 128. 8 plus 4, 12, 192. So now I have filled the first row. Okay, fill the first row. 0, 63, right? 192 and 1 to 62. Let's check the answer. Yes, 0, 63, 192. You can see 192. Of course, 64 machines. The usable address range is 1 to 62, right? 1 to 62. Is it clear? Okay. If it is not clear, you need to tell. So now we have allocated IP addresses for marketing because marketing is the biggest. Right? So that means 0, 0 is now allocated. Still we have 0, 1. But 0, 1 we are not going to allocate as a one block because we want to break it into 3. And we need to break it into 3. Okay. So now you need to allocate. And now if you want, you can allocate fixed size again. That is you borrow one more, that is 0, 1. Now we have control of the other bits. Okay. So that means 2 bits. So then another 6 bits. 6 bits. Now if you take one more bit, then it will be 1, 0, 1, 1. That is not 3, right? 2. So therefore, but if you take 2 bits, then 1, 0, 0, 1, 0, 1, because 1 is now fixed, because 0 is already given. So then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Then we have 4 subnetworks. And each subnetwork can have already 4 bits are used 1, 2, 3, 4, 2 to the power 4 because here we have 4 bits. 2 to the power 4 minus 2. That is 2, 4, 8, 16. 16 minus 10 is 14. But 14 is not enough. So therefore, you can't borrow 2 bits. Right? First, let's see whether we can create the 32-bit big one. Because remember, you need to now look at the next bigger one. Right? Next bigger one. Right? So therefore, rather than borrowing 2 bits, we are going to borrow only 1 bit from here. Right? 1 bit from here. So that means 0, 1, 0, 1, 0. And then we have 0, 1, 1 for the rest of the stuff. But here we are getting only 0, 1, 0. Why I took only 1 bit, not 2 bits? Because if you take 2 bits, it's not big enough. If it is not big enough. So now we have 192.174.19 0. Sorry, 192.174.19. Right, 194.174.19. Then 0, 1. 0, 1. 0, 1, 0. 0, 1, 1 is for the other two. Okay. That's 0, 1, 0. 0, 1, 0. So then we have these bits to play with. These bits to play. Okay. But here you can see they have assigned the biggest range to the last. You can see this is a very tricky question. So you can clearly see the operations is the 32 bigger one, but you can see clearly this is 79, 96. This is the biggest range. So that means it looks like they have assigned not 0, 1, 0 to the operations, rather 0, 1, 1 to the operation. 0, 1, 0 they have kept for stores and suppliers. So this is for stores and suppliers. So it's a very tricky question. So then this is for stores and suppliers, 0, 1, 0, because operations they have given the big range. You can see 79, 96, 159. Okay. So therefore I will take 0, 1, 1 for the operations. Okay. 0, 1, 1. Right. 0. So this thing is not going to change because we can have 0, 1, 0, 0, 1, 1. 0, 1, 0, 0, 1, 1. So let's assign 0, 1, 1 to the operations. 0, 1, 1. So then we have 6 more bits to play. So then the first address will be 0, 1, 1 and all zeros. Last address will be 0, 1, 1 and all ones. So that is I'm now looking at the operations. Okay. Because the next big address. I allocated 0, 1, 1 rather than 0, 1, 0 because by looking at this, so they have it has the biggest biggest IP addresses. Okay, so therefore network ID will be 192.174.19. That is not going to be changed. So then 0, 1, 1 and 6 zeros. 0, 1, 1 and sorry, 5 zeros. 0, 1, 1 and 5 zeros. So that is 0, 0, 0, 0, 0. The last address will be 0, 1, 1 and 1, 1, 1, 1, 1. And first I will write this one 1, 2, 4, 8, 16, 32, and 64. 32 plus 64 is what? 32. 32 plus 64. 692. Right? 32 plus 64. 4 plus 2, 6. 6 plus 3, 92. 92. Okay. You don't need 92, right? Anyway, now then what is this? 1, 2, 4, 8, 16, 32, 64. 1, because we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 8, 16, 32, 64, 128 minus 1, 127. Then this must be 127. There's a mistake. I think there's a mistake in the answer question. Right? You don't need 159, you need 127. Let's see whether it has been fixed in the answers. Yes, you can see this range examiner has not given an answer. You can see examiner has not fixed this. In the answer sheet, you must have the answer for each, right? So the reason is this value is wrong. Examiner has given a wrong value here. So therefore, examiner has not expected students to write this. Uh, okay. The reason is this value is wrong. Okay. So that is why here there's a note. You can see there's a small note here. Any or no answers to the three cells on the last row. Last row, three cells. If no answer is given or any answer, considered acceptable because it's examiner's issue, right? Examiner's issue because this is not actually 159, right? So we calculated and we found that that is not 159. So therefore, examiner has given marks to all the students uh, for the last row. That is examiner's issue, okay? Because it should be it must not be 159, right? It must be 127. So that is why examiner has given marks, okay? That is unfortunately examiner has made a mistake, okay? Uh, anyway, that is unfortunate. Examiners must have double checked their answers. But now let's look at that is 0, 1, 1, okay? But remember we have 0, 1, 0, 0, 1, 0, right? 0, 1, 0. Maybe that part is correct. So 0, 1, 0, now we are going to subdivide it into uh, we need 16 and 16. Okay, 16 and 16. So now 0, 1, 1 is given. 0, 1, 0, maybe we can borrow one bit because we want to break it into two. So basically we break it into this and this we are going to subdivide into two. Okay. So that means 0, 1, 0. I'm not interested in 0, 1, 1 because that answer is wrong. This question is wrong. Okay. Right. 0, 1, 0. Remember 0, 1, 1 is given to this operations department. 0, 1, 0, we are going to further divide like this because then we how many bits we have? 1, 2, 1, 2, 3, 4, 5 means 2 to the power 5 minus 2. 32 minus 2, 30. Right. 30 is big enough for 60. Right. Okay. So therefore it will be 0, 1, 0. One subnetwork we can say 0, 1, 0, 0. Right. Other one 0, 1, 0, 1. So that means we have two subnetwork. So you may get confused because the examiner has made a mess here also. Okay. So then we can say 0, 1, 0, 0. That is maybe for stores. And 0, 1, 0, 1. Remember we have this 0 and 1. And 0, 1, 0. So 0, 1, 0, 1. For the other 0, 1, 0, 1. So then the subnet ID will be 4 zeros here. Uh, uh, broadcast ID will be 4 ones here. Okay. So do we have that one? So then it will be this is 0, 1, 0, 0, 0. So this is my stores and this is my uh, supplies. 4 zeros. The last address will be 0, 1, 0, 1, 4 ones. Let's check whether this value we are getting 79. 1, 2, 4, 8, 16, 16 minus 1. This is 15. Okay. 15. So that is these things. So then 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, 32, 64. 64 plus 15. 79. Yes. So this one is correct. This one is correct. So this one is correct means, so this IP address is correct. So that means now we want to find this IP address. This IP address is this. All zeros. This is all ones, broadcast IP. So this one is 1, 2, 4, 8, 16, 32, 64. So this part is the same, 64. So therefore this will be 65 to 78. Okay, 65 to 78. So subnet mask. Now our separation is here. Separation is here. Okay, for that subnet. So that means 255 because all ones followed by all zeros. 255, 255, 255. And this is 4 ones, 4 zeros. What is 4 ones, 4 zeros? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4, 8, 16, 32, 64, 128. You add it. Okay. 16, 32, 1, 2, 4, 8, 16, 32, 64, 128. Okay. So 6 plus 4, 10, 8 plus 2, 10, 20, 2, 2 plus 1, 3, 3 plus 3, 6, 6 plus 6, 12, 12 plus 2, 14, 240. Now I have fixed this. Right. 64, 79, 240, 65 to 78. Let's double check. Yes, 64, right? 79. Okay. 79 is given. This is 240, correct? 255, 255 is 240. And usable addresses must be 65 to 78. Yes, 65 to 78. Correct. Okay. Right. So now we can fill this one. Fill this one. Supplies must be this because we have given 0, 1, 0, 0 to this, 0, 1, 0, 1 to the supplies. So then subnet mask is again the same, 240, because again the same level, 4 ones, 4 zeros. This is, let's see whether this is correct, 96. 1, 2, 4, 8, 16, right, 16. 1, 2, 4, 8, 16, 32, 64. 64 plus 16, 0, 80. 1, 2, 4, 8, 16, 32, 64. I think this one is also not correct. Okay. Because 64 plus is not 96, rather 80. Okay. So it looks like this one is also not correct. Okay. But let's find the final one. I think this one is also not correct. Okay. It can't be 96. Let's see the last one because that is what we need. Okay. 1, 2, 4, 8, 16, 32. 32 minus 1, 31. Then that is this part. 1, 2, 4, 8, 16, 32, 64. 4 plus 1, 5. 6 plus 3, 9. 95. So this must be 95. No, this is 96. This must be 95. I think examiner has made another mistake. Okay. No. No, can't be 95. This is 92, right? So I think I made a mistake again. 1, 2, 4, 8, 16. 16 minus 1, 15. Okay. 1, 2, 4, 8, 16, 32, 64. 64 plus 15. 5 plus 4, 9, 6, yeah, 79. So this must be 70. 79 is right, right. So 79 is here means uh, that is this one, right? So what we need is this one. What we need is this one. Sorry. 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, 32, 32 minus 1, 31. 31. 1, 2, 4, 8, 16, 32, 64. 64 plus 31. 5, 95. Right, 95. So this must be actually 95. Right, 95. but some reason this is wrong. Okay. So let's see the examiner. I think examiner has made a mistake again. Okay. Yeah, examiner has taken it as 111. That I don't know how examiner has got it. Right. I don't know how this examiner got 111. I think examiner has made another mistake somewhere. Okay. Because we did it correctly. 0, 1, 0, 0 here, 0, 1 here, 0, 1, 4. Maybe examiner has taken another bit. No, right? Because same subnetwork, 240. Subnet ID. Yeah, same subnet ID. That means only 4 bit. Okay. I think examiner has made another mistake here. Okay. This is correct, 240. I think this number is also wrong. Okay. I feel like this number is also wrong. Okay. So examiner has made a mistake somewhere here also. But you should get the idea how it is done. Right? You borrow the minimum number of bits. Right? It's like we are very, very not generous. We try to take the minimum and build it. Then further divide, further divide, further. Anyway, examiner has messed this answer also. Okay. Examiner has accepted this one, but I think examiner has made a mistake somewhere for this line also. Okay. Anyway, this is the idea. Okay, this is the idea because this is 20/25. First we took one bit, so then the other one we divided into two, and that one we divided into another two. Okay, it's a difficult question. Right? Difficult question because the examiner has really messed up the answers. So because not answers, the question. These values are actually not correct. So that is why we are not getting the correct same answer as the examiner. Okay, so that is something wrong with the question. Okay, right. So we'll continue the rest of the questions. Okay, anyway, now, yeah, 6:17. We will look at the other parts in the next class and then we will move on to other part means it take another 10 minutes. Then we'll move on to the other layers. Those layers are very easy to understand and we can do it fast. Maybe within another 2 sessions, we can finish network. Okay. Right. But again, go through today's session. Maybe you can look at the recordings also until you understand the concept behind subnetting, especially variable size subnetting, because fixed size subnetting is very easy. Okay. So you go with the bigger one, then another bit, which one bit is reserved for that network, the other bit is available, other bit with another bit we combine and blah, blah, blah. Okay. Right. We stop at this point. Right. Thank you.